All right.
I think that's actually that's actually the 76-degree angle.
Oh, so you lied to me.
Just a spoiler.
Okay. So that's 76 degrees, and everybody else was just going to let it go and not say a word. Okay. All right. Inverse tangent then of 880 over 110.
84.
880 over 110. And Nathan, what's that one?
83.
83. So theta 2 equals 83. And when we add those two together, final angle 159? 159? Okay. All right, now I looked through most of the ones that I got turned in, unless they get just turned in a little bit ago on the homework. I want to make sure we're good on these. 56, you graph over 1 period interval. 60 over 2 period interval. 2 period interval means you have 2 branches. Okay, I need to see both of those. I only need to have the points for the one. All right, Lane, did you fix yours yet?
No.
No. Oh, okay. Include the key points for all graphs, and you will be careful in making your scale. On the test, here's what I'll do. You're going to see, might as well tell you, you're going to see one of each. You have to do one with a tangent or cotangent, one with sine or cosine, all those with all the points. You will just have an x-axis, and you will have to mark the y-axis wherever it fits your points. So, the y-axis, if you want to put it right in the middle, it might work out that way. You might want to put it more on the left. If your first point is a negative one, you might want to put it on the right. Just depends. But you got to put a y-axis in there. And I just left the y-axis out so that you could put it where it makes more sense for your points on those. All right, for 56, here's what I need to see. Amplitude, period. Phase shift, these points. Negative pi over 3, 3/2. Negative pi over 12, 0. What's that next one? 2 pi over 12. If you just left it like that, that's absolutely fine. 5 pi over 12, 0. 8 pi over 12, 3/2. However you do. Now you need to pick an appropriate scale. I picked pi over 12, and I just marked it every pi over 6. But if you did pi over 6, that's fine as long as you put the points in the right spot. But it should look something like this with the cosine starting from high, going to low, and then ending up high. But the point, you've got to have the points listed. For the second one, number 60. Okay. Tangent. The asymptotes are using negative pi over 2 and pi over 2. You got to solve for that. So I need to have them at pi over 24 and 7 over 24. The points in between there, 5 pi over 48, 8 pi over 48, 11 pi over 48. I'll have this on Canvas. You can look at it a little bit closer if needed. And then you do have to have 2 branches. So the one branch, I went over pi over 24. And then I just did another branch to the left. Okay, on it. But do have 2 branches on there. The middle point should be halfway in between your asymptotes. And then each point to the right and to the left should be halfway between the middle point and each asymptote. That's just another guide to kind of help you figure that out. If you don't go every 48, it's not quite as easy. Okay, for those. All right, so those are those 2. You gotta know how to graph it. It's on the no calculator part. I'm not just in case you're wearing no red calculators either. I mean, just you got to use your brain. That's it. All right, questions. All right, I wanted to go just through a couple things, and I'll give you some time to work on the review. I just want to make sure I hit a few things. You got the Chapter 5 review. I believe yours says page 613. Is that right? All right, this was from an old edition of the book, so the numbers are right. The numbers are right. You just should say 613 for that. Go through there, list everything you need to know. First question, all the 6 graphs from negative 2 pi to 2 pi. You gotta have it on there. You need to know the domain, range, period, and whether it's even or odd. I'm not gonna ask you for everyone, but I will ask you for a couple. And this is what we just did with sine, cosine, tangent, or cotangent. We just did that. Composition of functions was yesterday. And then you got the calculator part. Make sure you read through that. All right, a couple ones here. It's been a little while, and sometimes since we've done all unit circle, people sometimes think that the hypotenuse is always 1. It doesn't have to be. So let's take a look at this one here. Find the exact value of the 6 trig functions for the angle through the point -5 square root 11. All right, so what do we got to do for that? So I want to know, well, make sure you understand here. Okay, I want to know what the sine of the angle is. I want to know the cosine of the angle. I want to know what the tangent is. Cosecant, secant, and then cotangent for that. And you can just estimate here. So -5 square root 11. I got it pretty close there. And if you want to drop that down, this would be your -5. And this would be square root of 11. You're going to need to figure out that R value. It's not 1. It does not have to be 1. All right, go ahead and figure out that R value. And so that's going to be -5 squared plus square root of 11 squared equals R squared. 25 plus 11. I get 36. And you should get that value as 6. Okay, so that hypotenuse is 6. So now your sine, hold on here a second. Move that up a little bit. All right, sine of theta is going to be opposite, or it's going to be, we talked about this as y over r. So y value is square root of 11 over 6. Okay, for that one, and it's in quadrant 2, so it should be positive. Sine should be positive. And then cosecant is r over y. And so that's going to be 6 over square root of 11, and we will rationalize here. 6 radical 11 over 11. Cosine x over r. What's my x in this case? It's -5, so it's -5, 6. So -5, 6, and r over x would be -6/5, and then you got your tangent, you got your cotangent. Okay, but now make sure you know that you're using sines as well. Let's see, tangent and cotangent. Move those up a little bit. Y over x. This is x over y. Y over x, what is the y value? Square root of 11 over -5. So the whole thing's negative. And then -5 over square root of 11. -5 square root of 11 over 11. So I just want to hit one where it goes through the point. Sometimes you just kind of forget about that. And make sure that R value is not 1. It's whatever you get from the Pythagorean theorem. All right, go ahead. Take a look at this one. I want you, do not graph this. You'll get, this is another way we can go ask you a question. Do not graph this on the amplitude, on the period, on the phase shift, and I want the range. All right, see what you come up with. Fix those, what we can do there. Yeah. How are you getting those? take them. I'll try. Thank you. Okay, one thing you gotta watch in your phase shift, you gotta factor out that 3 first, so make sure you do that. So you got y equals -2 cosine 3 parentheses x plus, and then when you divide by that 3, it'll give you pi over 6. Okay, don't forget when you factor that out, you're taking pi over 2 divided by 3, which is pi over 2 times a third. So we get pi over 6. All right, amplitude. Gavin, what do I get for amplitude? 2. Remember, it's the absolute value of that number in front. So it's 2. Mackenzie, what do we get for period?
2 pi over 3.
Good. 2 pi over 3. 2 pi over 3. Tony, how about phase shift?
I got left pi over 6.
Okay, left pi over 6. This is acting up today. And if you can either do left or you do negative pi over 6. Those are equivalent. There we go.
It's plus.
Yeah, but remember you do the opposite. So if it's x plus pi over 6, it's going to the left.
Yeah.
So so you got to write down negative pi over 6 for the phase shift. Okay, for that one. And how about the range? Peyton.
I have 0 to 2.
0 to 2.
Yeah, because it goes up 1.
It goes up 1, but also what happens to it?
Oh, it gets multiplied by 2.
It gets stretched. Yep. And so that stretches it from -2 to 2. What happens when we move it up 1?
-1 to 3.
-1 to +3. Good. So -1 to +3. Okay, good. All right, so you got your phase shift, got your amplitude, got your period. All right. Okay, these, I just want to double check. Go through a couple of these. Y equals inverse sine of negative square root of 2 over 2. What angle has a sine of negative radical 2 over 2? In radians. In radians. All right. Think about it. Go ahead, you got it? He says negative pi over 4. Lane, do you agree?
Sure.
That's a good, just agree whether you do or not. Negative pi over 4. I agree. Oops. What is going on with this thing? I need to restart it. All right, negative pi over 4. Negative 45 degrees. Remember, which quadrant can sine come back in? Inverse sine. It can come back between negative pi over 2 and pi over 2, which is quadrant 1 and quadrant 4. And if it's going to be a negative, it's got to be in quadrant 4. You can draw that out if need be. Okay? And that's going to give you a 45-degree reference angle. All right, how about inverse cosine of square root of 3 over 2? Okay?
Pi over 6.
It says pi over 6. That is correct. Because that's got to be in quadrant 1. That means my x value is radical 3 over 2, which means I have a 30, 60, 90 triangle, and that means that's going to be 30. That side's going to be 60. And you can make that 1. In this case, you can make the hypotenuse 1. Okay? And then this would be 1/2. So it's got to be square pi over 6. Okay, inverse sine of negative 3. Okay, inverse sine of negative 3. Nathan says no.
Shaking my head.
Shaking your head. What does that mean?
That is no inverse sine of -3.
Can't do it. So we write undefined. because that number has to be between, this number here has to be between -1 and 1 for inverse sine. Okay, so it's not. You can't do it. All right, inverse secant, negative square root of 2. All right, before you say undefined, you got to go think about it a little bit. So we want to talk about not inverse secant, but inverse cosine. So think about this as the inverse cosine of 1 over negative square root of 2. Simplify that, and you're going to get inverse cosine. What is going on here? Inverse cosine of negative square root of 2 over 2. Negative square root of 2 over. All right, think about that one. That does have an answer. Think where it would be and what it would be. Is it direct? All right, good. Emily, you got it?
No.
No? Still thinking? Cole DeLuca.
I got 3 pi over 4.
You got 3 pi over 4. You confident in that answer?
Pretty confident.
Pretty confident. All right, it is correct. It is correct. Just more ahead, just so to make sure we know. Find the exact value of y in radians, or state that is undefined. Just making sure. 3 pi over 4. Cosine, remember that is defined from 0 to pi. Okay, and when it is negative, it's going to be in quadrant 2. Square root of 2 over 2 here, or negative. That means we got a 45-degree reference angle. It is 135 degrees, but you got to convert it to radians. So 3 pi over 4 would be that final answer. Okay. And now one of the things that were on the review that I want to take another look at it, we've done a little bit of this. Identify equations given a graph. I'm going to give you a graph. You're going to give me the equation. Okay, so let's take a look at one of those. Okay, now technically or theoretically, this could be a sine or cosine graph. Just depends on how you shift it. I'm going to tell you I want it to be a sine graph. Right? So it's going to have y equals sine of something. So if it's going to be a sine graph, what you need to look at is the sine curve, which would start at 0 and go to the maximum, 0, minimum, and back to 0. That would be one period. That would be one period. Okay. Finding the period is going to be the difficult part of this. I will let, if you can't see it back there, Moorhead, I'll let you know that this is pi over 6, and this is 3 pi over 2. And finding the b value is going to be the hard part on this one. I'll give you a chance, though. I'll give you a chance. Figure it out. Coming up with trig graphs?
I just like to watch trig graphs.
We all did a big test of them. I'm sure you're going to let you know.
Once you figure out sine and cosine are really just the same thing.
That's what
The rest is easy.
it is.
Skip all the tangent ones. Nobody does tangent anymore.
Oh, don't tell that. You think it goes to yeah.
He's only gonna put like 2 tangent ones on the quiz. Just do everything else perfect.
I already told him one of each. Oh, yeah. Get the bar. Okay, you should get y equals 2, sine of 3 halves, x minus 5 over 6. Okay.
3, 2.
What'd you get?
I just got 3.
You get 3?
I did too. We just skipped this stuff.
You skip over.
Alright.
All right, this is a difficult one. What is the period? The period is 3 pi over 2 minus pi over 6. You got to subtract those x values in order to find the period. And what do we get when we subtract those? This is 9 pi over 6 minus pi over 6, which is 8 pi over 6, which is 4 pi over 3. So that's the period. And we know that if we know the b value, we also know that the period is 2 pi divided by whatever b is. Well, since I know what the period is, put that in here. So it gives you 4 pi divided by 3 equals 2 pi over b for that. And so now some of you say, oh, well, that goes from 4 to 2, so that has to go from 3 to 1.5. You know, something you can do that as a proportion, or you can cross multiply to solve and say 2 times 3 is 6 pi. 4 pi times b is 4 pi b. Divide by 4 pi. Divide by 4 pi. And then the pi's cancel and it reduces to 1.5 or 3 halves. So however you do that, you get 3 halves for that value. 2 because it's been stretched up and it's been shifted right pi over 6, so it's going to be x minus pi over 6. So theoretically, you could graph that on your calculator to see if it matched up with what you thought it was. Okay. All right, you get the rest of the period. Work on that review. I got to go through a couple of homeworks. If I saw a mistake on yours or 2, I might call you up and see if we can make sure we figure it out.
There's that one right there. Define the period. I just think so to get from like pi over 6 to pi over 3, you just add pi over 6. So I just did that.
1, 2,
times
3,
4
4, 5,
pi over
6, 7, 8. Yeah.
We get 4 pi over 6 is the period, and then I got that to be 2 pi over 3
For the period?
Yeah. Because you add pi over 6 each time, so I just did that by 4.
Why by 4? That only takes you to there.
Yeah, but aren't we supposed to do like times 4 to get the? Or,
The period has to go all the way to that point there. That makes sense? Which would be 1,